Hello, my name is Andrey Soares. This presentation introduces the EBMonFHIR project, which is making evidence from clinical studies interoperable and computable using the FHIR standard. Since 2018, the EBMonFHIR project has been extending the FHIR standard to support data exchange of biometric evidence in a machine-readable and executable format. FHIR stands for Fast Healthcare Interoperability Resources. It is a set of building blocks to represent patient health data in a standard format. The EBMonFHIR project has extended FHIR to include evidence and evidence variable resources, and most recently, the COVID-19 Knowledge Accelerator project, also known as COCA, has developed additional FHIR resources for representing evidence report and citation. This is an overview of the computable evidence transformation, where study results are extracted and transformed from different sources such as published study reports, gray literature, and literature database, and stored as machine-readable evidence in an interoperable standard format using FHIR. This source can then be used by a variety of evidence users. This slide shows a high-level view of the data elements for the evidence, the citation, the evidence variable, and the evidence report. Here's a more detailed view of the evidence resource. The evidence resource allows expression of the components of a PICO question in a codable and reusable format. It contains a set of elements to represent information about the evidence, such as status, synthesis type, study type, statistic, and certainty. The FHIR data elements have cardinality to indicate whether they are required, and types to represent what type of information can be stored by the elements. Some items, such as status, use values from a predefined list of codes from a code system. For example, the status can have the values draft, active, retired, or unknown. In FHIR, some elements are backbone elements containing sub-items. For example, the statistic element is represented by a set of elements as shown here. These elements are used to represent the statistic of evidence. In this example, FHIR is representing the statistic of a odds ratio with 1.27 and credible interval of 95%. This FHIR resource can be created and visualized using the FHIR platform. It has builder, viewer, and converter tools, and a list of FHIR resources. Please visit the FHIR.net to learn more. In this example, we can see parts of the evidence resource in a human readable format on the left and a computable readable format on the right. The intended population is represented by a group resource that contains inclusion and exclusion criteria. Then the group resource contains the specific representation of the inclusion and exclusion criteria. In this example, it includes hospital admission and disease caused by SARS, and excludes life-threatening severity. These characteristics are mapped to specific SNOMED codes. The evidence also has elements to represent the certainty of an evidence. In this case, members of the COCA project evaluated the certainty and quality of the evidence in a multi-participant collaboration of a post-publication review. This example shows that the selection bias was categorized and represented with the code no concern by 3 raters. COCA has several working groups focused on different aspects of computable evidence. Anyone can join them. Here's a tiny URL link to visit the COCA webpage and the current list of our weekly meetings. Thank you.